Not necessarily. Now, this is any triangle. That's the one, I think. So that's the other big one. So I'm gonna show you a quick. Well, remember, he's already had some geometry. He needs the rest of it. Well, yeah, this is you actually learned this before pre-algebra. You learned this way before that. So, well, you did. I don't mean you remember it, but you did learn it. Well, again, your class went over it. Whether you were in class paying attention, I can't answer that, but it is something that was taught. All right, so here's the big one. Between this and one old thing you're already supposed to know, that's like 90% of what you need to know in problems. And then you just have to understand how to set up the equation and do the algebra. The internal angles, and actually, I'm sorry, interior is really what they're called. I always say internal, but that's a mistake. They're called interior. So those are interior angles. I always kind of skip over some stuff, so I'm not going to do it this time. An angle is that. That's an angle. So sometimes in triangles, for whatever reason, we forget that they're just angles. So that's one of the angles. That's one of the angles. That's one of the angles. Those angles, if we measure them with a protractor is the tool for measuring angles, you figure out if you could perfectly measure them, and then you added, so just as an estimate, these are pretty close. I don't know, we'll say one's 23, and we'll say one's 25. And then this one would have to be, is that 48, 132? 132, because all three interior angles of a triangle, if you add up their measures, and they're measured in degrees, if you don't remember that, that's how you measure an angle, they have to add up to 180 degrees. So that needs to be an automatic thing when you're dealing with triangles, especially if you're dealing with the angles of triangles. The three interior angles add up to 180 degrees. So in this case, I could say angle B plus angle, I don't know why I said angle B in here. Angle A plus angle B plus angle C has to be 180. I don't care what the triangle looks like, how skinny it is, how fat it is, if it's a right angle, if it's a super teeny tiny triangle, or if it's the size of a stadium. If it is a perfect triangle, meaning all the sides are straight, the angles will add up to 180. No exceptions. That's why it's super important. No exceptions. And again, interior means inside. That seems very obvious, but when you get into drawings that are more complex with like 4 or 5 triangles all in the same figure, because we take one big figure and split it into a bunch of different triangles, it gets a little tricky. So interior means you find the sides of the triangle, and then the angles that are inside those sides are the interior. We're going to be 3 of them. All right. Any questions on that? It's nothing super crazy yet. So just to help you remember that, if you have a rectangle or a square, is even easier to kind of imagine. How many degrees if you add up all the angles of a square? 90, 90, 90, 90, right? That's the definition of a square. They all have 90 degrees. So it's 360, right? If I take that square and if I divide it into 2 perfectly equal triangles, how many degrees then have to be in the 2 triangles each? Yeah, we're just splitting that 360 into 2 perfectly equal halves, right? So that hopefully is something if you forget. And again, that is about the measure of angles. So every year, I say in a different lesson, what's true about the sides of a triangle? They add up to 180. The sides don't add up to any specific. Just think about it. You could have a triangle, again, that's that teeny tiny small, or as big as a stadium. The sides can't add up to one specific number. For a triangle, however, The measure of the angles doesn't change if I zoom in or zoom out, as long as I keep the scale the same, which that's a lesson for later, but I'll just show you what I mean. I mean, you're all pretty familiar with zooming in and out of pictures, I know, so it's kind of the same thing. If I take this figure, we'll do it using A, but it's the same for all of them. So there's angle A, right? Again, it's measured like in the, oh, what are the points of a triangle called? A, B, C, they're points, but another word that I'll use. What's the V? Vertex. So vertices is the plural. Each point is a vertex. It just means the corner of the figure. Any polygon has vertices. Rectangle, square, triangle, doesn't matter. It's just where two lines meet, sort of really like, it could be two lines. Again, so when I say vertex or vertices, it just means the corners where the angles are. It's the specific point, technically. So point C is the vertex. So with that in mind, that's A. I can get smaller. And if you'll notice, that line, like it still touches the lines. Nothing changes. Like it doesn't matter. It changes a little bit there. The measure of that angle does not change, even as I zoom in and out. That's why all the angles can always add up to 180. Even if I zoom in and out, it doesn't change the measure of the angles because all the sides stay in the same proportion. Since they stay in the same proportion, the angles don't change. So again, just you got to memorize it, memorize it. The three interior angles of a triangle add up to 180 degrees. So yeah, we can go ahead and move into this. So this is in your book, page 274. I think it's more toward the bottom. So if you want to turn to that page, you can make notes around it instead of copying everything.
Yeah, Mr. Gill. Thanks a lot. Right here.
Okay.
Right, because are we getting decimals?
I think they're actually I don't remember. Sometimes there are decimals. I don't
I
remember.
just include the first two.
All right, that's fine. Yeah, I don't care where you're around. I'll be grading your work. So
This.
all right.
I got.
Oh. All right, so we talked about interior angles. Now we're going to talk about what's called an exterior angle. If I extend the side of a triangle, so all they did is they took the side and they extended it. It creates an angle outside of the triangle. It's labeled with a 4. That angle is an exterior angle. It's exterior means outside. So it gets a little trickier with some figure. Is that the only way you're doing?
Yeah.
Okay. So I'll show you what a figure can look like. We're not going to really do much with it today, but you'll definitely see some problems, I'm sure, in the future with it. Maybe not even this week. What is true about angle 2 and angle 4? Not vertical, because that would mean they're on the opposite side. They're adjacent is the word they are. But there's something, and again, when we first did vertical, we learned this one also. And I said, you're going to forget these two things. And sure enough, we forgot these two things every class. Nope, not necessarily. I mean, it could be, but not necessarily. Oh, actually. Yeah. There, somebody stole your thunder. I don't know like you're about to say it. So this is the same thing we learned before. I mean, this is not new. If I have a straight line, how many degrees in that straight line? 180, right? We learned that before. Like every line, if I take an angle and if I open it up all the way into a straight line, it's not a very good straight line, but that's fine. So if I split it into two angles, angle 1 and angle 2, what has to be true about angle 1 and angle 2? They have to add, if the original line was 180 and I didn't change the original line. So again, actually, let's do it backwards. I didn't do it this way in the other class. We'll do it this way. So if I know If I know that is 180 degrees, remember we draw, I would tell you, like, you guys don't follow any of the processes I give you, and that shows in the quizzes. I'm telling you to do that. You should do that if you're struggling. If you're getting A's and B's, and you're fine, but this will help you because now when I draw an angle in, or if there's already an angle there, I know that arc is 180 degrees. I didn't change anything. I split that arc into two angles, but there is still 180 degrees in that arc. If I would have drawn four angles in, if I would have split it four times, there would still be 180 degrees in those four angles if I added them up. It would have been angle 1 plus angle 2 plus angle 3 plus angle 4, 180 degrees. Between that concept there, between the concept of the three internal angles adding up to 180 interior, that's like 90% of your triangle. Now, the figures will get more complex, the images that they give you. There'll be a lot more going on than this figure right there. But you're just going to keep using those two concepts most of the time. There is a concept with exterior we'll do in a minute, but you don't even need that every time. Just because there's an exterior angle doesn't even mean you need it. There's other ways to figure it out. Sometimes you do have to have it. All right, so next. So make sure you make your note. Oh, those are called linear pair, collinear, the angles that, so again, what we say is true about 2 and 4. They add, let's say they add up. They don't equal 180, they add to 180. So if I were to take some lines, I think this is the right line here. And if I were to extend all the sides, hopefully I can get that. I'm going to extend all the sides of that triangle. I'm going to create more exterior angles. So we'll call, if that's 4, we'll call that 5. And again, it's going to get way more confusing than this. But the way you, in this particular image, the way I know where the angle is the other side's flat. Like there's no angle on the other side. So it's pretty easy in this figure, hopefully, to tell where the exterior angle is. What's true about that pair of angles? Yeah, same thing. They're on the line, right? All I did is split the line into two angles. So what's true about that? Same thing. They add up to 180, right? So here's your next note. I mean, you can circle them in the book and write all this in the book. You're writing your pages, whatever you do. I know. So if that's 180 degrees, that's 180 degrees between those two angles, and that's 180 degrees. I don't know why I did that. Between those two angles, how many total degrees do you have between the interior and exterior angles? I have to use calculator. Total degrees. I gave you the numbers. All you gotta do is add them in the calculator. Well, then take a guess. Close. 540. So we know then, and again, this is only between the 3 exterior and 3 interior. You actually have more than 3 exterior. We're going to talk about that in a minute. But when you draw in exterior in a figure, you have to understand there can be another. I could have continued this line going out that way, which would have created another one, but we only use one interior angle at a time when we're doing this calculation. One interior and exterior, I should say. So we're only using these two, and then these two, and then these two when we talk about this concept. And frankly, if you don't understand it, you can just memorize it if you really, really have to. So if that's true, which we just showed it, you know, it's true, they're all 180, 180, 180. What did we say the sum of the interior angles are? We started the whole triangle lesson with 180, right? So if I know that has to be 180, do the math. Just do the math. What are all the interior angles going to add up to? I'm sorry, exterior angles are 180 plus 180 about 40.
Yeah.
So what are they going to be?
360.
360. So here's your next note. Again, you understand the logic. You don't have to memorize it. If you don't understand the logic, then you got to memorize it. The sum of the exterior angles. Again, only 3 of them at a time. It's got to be the correct 3, or else this doesn't help you. The sum of the 3 exterior angles adds up to 360. Interior, 180. Exterior, 360. Some problems that they give you, you have to know that. I think I give you problems where you can actually figure it out other ways if you forget that stuff.
That always has to be 360, like on any shape, right? Like no matter what, 360. Or then, like on every single shape, it's gonna be 360, like that outer angle, right?
I mean, I wouldn't say for every single shape.
Like most things.
I don't know, that's a good question. I have to go back and look at it. But it doesn't really come into play, like you don't really, I mean, it would definitely be true for 4-sided figure because you're 90, like take a rectangle, 90 and 90. So, that might be true actually. Yeah. I mean, again, it's not going to come into play in anything really for us to try.
So how do you get 360? It's like you add,
Well, we know this, right?
yeah.
So if we know this is 180, what number plus 180 would equal
Oh, so
540?
you have to-
We basically subtracted 180 out from this to figure that. Like that's like our variable. So we say, okay, well, to solve for that variable, we subtract 180 and subtract 180. That gives us. All right. And there's one more thing we'll do with exterior angles. I think we're on to that now. This is a definition that I didn't even go over in the other classes. We talked about the concept behind it, which is what we're about to do now. But you may want to just note what I call them opposite. I guess they're really remote is the word I should have been using. So remote interior angles. I call them opposite interior angles. I don't even remember ever learning remote. So I want you to solve for X. Solve for X. Could be. This is easier. There might be one on your quiz that is this easy, but maybe not. There may not be anything easy. It would not be enough to get a passing grade. I know that. It gets you started for a second. Oh no, right now. Everybody to do it. The main reason we're doing this one is because there's a concept that end with that is, again, something that you understand, you don't have to memorize it. You don't understand it, then you're going to need to memorize it as well. Because again, some problems you have to know. Well, I can't believe you have to not to think and calculate. It's only sit on this. Both sides. All right, so again, I told you between these two concepts that we're about to use, 90% probably of triangle problems that you'll see in this class at least can be solved. Well, until we get to really difficult things. Right now, this lesson. What are the two concepts? One we reviewed, we had learned it a long time ago. One was sort of new. You did learn it, but you didn't learn it in this class until. The one concept, sum of interior angles, has to add up to 180. What was the other one? This is the one we reviewed. We learned it a long time ago. Well, that's the first one. That's the one we just went over. But what's the one we reviewed? I just did it when we did the exterior and interior, and I said, what's true about angle 2 and angle 4? What's true about angle, what I call them?
Oh, they're adjacent.
So if they are adjacent, so again, I don't care how you explain it, but it was this. That, so if they are adjacent, if they make up a line, all we did is take that line and split it into two angles, or the way I say it a lot, if we can draw a semicircle through it. Semicircle meaning we go from one spot here all the way through and we go 180 degrees, right? That's why I call it a semicircle. It's 180 degrees. Then those two angles have to add up to what? So that's the other concept. Between these two things, they're called collinear pair, so I'm going to write that. But if you want to write semicircle adds up to 180, like whatever you need to write. That's the second concept that you're going to use all the time in these triangle problems. Actually, not just triangle problems. Anything to do with angles, you're going to use that all. I said anything to do with angles, you're going to use that concept a lot.
Wait, so. Subtract 180 from 128 to get 50.
So now let's talk about solving. I cannot solve for x. Well, actually, you can. That's kind of the point of this. We're gonna learn another concept, but I can't say, well, wait a minute, x plus 51 plus, I don't know what that is. Like that would have to be another variable. I can't solve that if I have two variables in it. So if I can get rid of this variable y, which I can, because I can solve for y, I would say, okay, well, I know right here where the semicircle is, those have to add up to 180. Which means if I only have one variable in an equation, I can solve. I would subtract the 128 from both sides. And what I get, 52. So now that I know this angle, so if I know, anytime you know a variable, you don't need the variable, so we got rid of that. So now I can say, okay, well, that means I can change this equation and only have one variable. Now you can solve for the x.
It would be 77, right?
77 is correct. So that much simpler problem algebraically, meaning the math was easy. The same concept you're going to use over and over again in these problems.
For all of them?
A lot of them, more than half. You just have to understand sometimes, like you're going to see one in a minute, where you got a lot more going on in the angles. Like it's not just going to give you a number in two of the angles. It's not just going to give you just x. It's going to be like 2x subtract 2, x plus 8 or something like that. It's still just a number. Don't freak out when they start to put more stuff in the angles. I do this all the time to you guys. $20 is $20. It's got a value of $20. I might have a $20 bill. Davion might have 2 10s. Rhea might have 4 5s. We still all have $20. It doesn't matter what it looks like. It's just a number, just a value. The angles are just numbers. They're just values. They're going to show them in different ways, but they're just numbers that we're trying to figure out. So with that in mind, oh, actually, tell you what. Before we do that one, there's a problem you can do on page 274 at the top. Super easy, easier even than really this one. And then I have to tell you one more thing on this one anyways. So do that one really quickly. It should be like, you should be able to do that in like 2 minutes. I'll go over it, but
274.
top of, I believe it's right, top of 274. Isn't that a problem with like a big triangle that's split into two little triangles? There.
That was what I.
I'll put it up. You can just draw it real quick. It's a simple image. Well, I do have to go way back for it. Here. There, that one right there. But just, you don't need to know the words or anything, just draw that out, solve for angle 1, 2, and 3. I'll give you a minute. You don't get finished, you're gonna have plenty of practice. Oh, I will use IXLs a little more in this lesson. Actually, I looked at your quiz on the quiz this Friday. Some of the problems are straight from IXL, so you're definitely gonna want to practice. That's for the lesson we do tomorrow. But some of the IXLs from today is perfect. Went. We'll go over in a second, so. All right. Looks like people are kind of wrapping up, so I'll give you another 30 seconds. No pressure. You were not at the game last night, Bruce. There were some varsity girls there cheering them on. It was fun. Actually, their JV was pretty good. Yeah, you could tell they knew what they were doing, and they had some girls that were for JV, especially were pretty good athletes. All right, so there's one place to me that is obvious to start, but there's really two places you could start. Doesn't matter where you start. A lot of times people are starting ones if they're going 1, 2, and then 3. But just know the numbers don't mean that's the order you're going to go in. So, and again, you can in this one, so it works. But if you ever try to do one, like figure 1 out and you can't, don't think that it goes in order. There may be a chance that you need to do it in a different order than the order that the angles are numbered. Yeah, because I normally start at 2 personally also like that. When I look at it for whatever reason, 2 is the one that jumps out.
Because I feel like that's the easiest, because it's just like, oh, 57.
I mean, they're both easy. Like actually,
1 and 2 are the easiest.
one is actually probably even easier because it's just one number, but yeah. So what's the concept we need for angle 1?
Supplementary.
So collinear, they are a supplementary pair. But it's this thing here. I can draw a semicircle through it. So if I can draw a semicircle through it, every angle that semicircle touches has to all add up. All the angles, I should say, that touches could be more than 2. Don't think it's always only going to be 2, but all the angles would have to add up to 180. So in this case, it's just angle 1 plus 57 is 180. So if you do the math on that, 123, is that what you get for angle 1?
Yeah.
So angle 1 we now know is 123. I'm just gonna put an arrow out here. Oh, I'm gonna go over this more when we get into more variables. If you ever get confused, because sometimes they try to cram a lot of stuff into one image. If you get confused about whether stuff, numbers or variables, or talking about sides or angles, if there's a degree symbol, it's talking about angle. So that's an easy way to fix that. And I'm telling you, you're gonna see some confusing stuff when we get to problems that have stuff about sides and about angles of triangles. Just remember, degree symbol means we're talking about the angle. You don't see the degree symbol, and I'll show you an example. Actually, I'll just show it to you. So here's an example of when it would be super confusing. Or more confusing. So we draw this out, and there'd be other stuff other than what I'm about to write. But a lot of times they'll write something inside the triangle like that. And kids are like, I have no idea what that's talking about. Is that talking about the length of this line? Talking about the measure of this angle or the measure of that angle? Or maybe even they think something up here. If there is no degree symbol on it, then it means it's that line. If there was a degree symbol, then you'd have to figure out which angle it was talking about, but it would be closer to one of the two angles for sure, or it might even have an arrow drawn in. Sometimes it might be outside and draw an arrow in. That is typically that's going to be for the measure of angles, so there'd be a degree symbol on the outside. But just remember, look for the degree symbol. You don't see the degree symbol, then it's about the length of a side somewhere. Oh, so we got to finish this off. So now that we know that's 128, I guess we can just go in order. So we can do 2. What do we need to know to solve for angle 2? Like, what's the concept? Yeah, that's the 3 interior angles. Yeah, 3 in always, every triangle. 3 interior angles have to add up to 180. And we already have all the numbers we need. That's measure of angle 2, but that's fine. So if we do the math on that, what's that? 128 from 180. So 52 again. What you got? 52. Yeah, they use 52 again, apparently. So there's 52. And then lastly, angle 3, there's actually 2 ways to solve for angle 3. The simple way is to look at this triangle here and say, oh, well, that's 128 plus 28. Add that together, subtract. But what's the other way? What else could you do? Well, you don't know that again, don't jump to conclusions. Yeah, they look the same, but I don't, maybe this is 28.01. Like that's kind of like assuming that an angle is a right angle. We can't assume they're the same. There'll be some things we learn later when we talk about congruent triangles and specific types of triangles that might tell you that, but right now, there's nothing that we know that tells us those are equal.
You're gonna mess up your math with the check off, but you wrote 128.
Oh, did
Yeah, you're gonna mess up your math if you went to just go off with that.
So what else? I wasn't gonna use that one anyway for 3, but you can, so if you did it. What, and that would be a way I could have checked, and I'd be like, wait a minute, why I get 2 different answers from you? So, but here's the thing, they're not good. If I draw arc, am I going through angle 2? Did I touch angle 2? Here, let me erase it. Remember, your arc, your semicircle has to touch the angle. I don't touch angle 2. I can't say 52 plus 1 equals anything. Or 3. Like I'm not, I try to, like there's no angle. I mean, I can't draw an angle from here way over to there. They've got to be right next to each other to do that. So the semicircle thing is only for angles that are next to each other. Just making sure that is something that kids got a little confused. Actually, too. How many triangles are in this figure? 2. It's actually 3, right? Because I got the 2 little ones that are easy to see, but I got a big triangle. Well, I know this one now, right? We saw for that. What was that? 52?
Yeah.
I erased it. Don't I know this angle? That's the big triangle angle. I don't think it's 90, it's 98.
That's 99.
99, I'm sorry, 99. So if I know two of the three angles of the big triangle, now I can use the three angles of a triangle at a 180 with the big angles. So I could do it either way. Since we solved for one, I could add these two together. Should get the same number, right? Because three's got to be the same number. So whatever these two add up to be, these two have to add up to be the same thing. Because three is always going to be the same. What did you guys get? Just so everybody has for angle 3. So 29. So for everybody that's doing it, 29. I forgot one thing. Oh, actually, it's on here. I forgot to tell you in this problem, there's another concept. I think I forgot. I can't remember saying it. That's fine. Nope. There. So we know this is 52 degrees. We subtracted it from 180, right? What's true about this angle and these two angles? What's true about the 52 and those two angles? They have to add up to 180, right? So if you think of this as one number, think of it as one number. Those two added together are going to give you one number, right? Whatever that number is, plus that angle has to be 180. Well, isn't it true, though, that whatever this number is, this number plus that also has to be 180?
Yeah.
Because it's linear pair.
Mhm.
So here's the concept, and this is, again, always true for a triangle and an external angle. Actually, let's circle them in red. So these red circles have to be the same number because you're always adding those red circles to this to get 180. The only way you can do that is at the same number. So the external angle of a triangle is equal to the sum, I call it, of the two opposite interior angles. It's not external, exterior. The exterior angle of a triangle is equal to the sum of the two opposite interior. That's if you go to the page before, I think it's, actually, this isn't even in your book. It was that one piece where it said remote interior. That I'm calling that opposite. So these are called remote interior relative to the exterior. So that's the exterior. The opposite are called remote interior. I'm not going to quiz you on like names, but just if it ever pops up, remote interior.
Is that for the?
It depends on wherever the exterior is. So again, these two would be remote interior for the external or exterior angle that's way over here, because it's got to be opposite side. So every pair of interior has, so these two down here, yeah, I'm just, so these two angles here, the two interior, would be remote or opposite of the exterior angle up here. So that exterior here, or really this would also be an exterior angle depending on which way you drew the line. So whatever this number is, it equals the sum of those two. It has to, because you're always adding it to this to get 180. If you don't understand that, just you got to memorize it. What's that? The remote interior, which are the two opposite angles, are equal, the sum of these, if you add them together, are equal to the exterior on the opposite side. Again, you'll do enough problems where you'll get to the point where you just remember it if you practice it enough. And in my quiz, I don't even know that you have to be able to do it.
That works because the two angles, like that's where they conjoin. That's what we're going to do.
Well, it works because you're always adding up to be 180, whether you're adding it to be 180 with the like the exterior and its interior right on the same line, they add up to 180, right? They're collinear on the same line. But I also have to be able to add that interior angle with the other two angles and get 180 because they're all interior
It's
angles.
like that figure that they always give us, where it's like the X and it's got like one angle, and then it's got the two.
It's not really, I think are you thinking of vertical angles?
Yeah, it's where it's like,
It's not really because of vertical angles, because they're not crossing, they're
But
not
it looked
dealing with
like-
opposite angles.
because they go like this and then they go and meet back up, right? Like, cause of how, like, it's like this.
If there's any way to associate that with vertical angles. I mean, there's no angles going,
Like
Through,
those
like-
lines, like,
this is it, this is all you get, there's no vertical angle.
not of vertical things where like they're touch, like to where they intersect.
All I can think of is vertical. Saying or something. You're talking about this that we did, and then we gotta move on, but you're talking about this?
Yeah,
Trying
like
to
if they're,
figure that?
because they go like that.
Yeah, but we don't have, I mean, there's no cross anywhere in that figure.
Well, I'm saying those two, like if those are exteriors up there, those two lines would go out like.
Well, yeah, but again, it's true even without them. I don't need that, and we still have that concept, and there's no vertical angles. The only exterior angle is that, and that's not a vertical angle of anything. So, I can't think of a way to equate that at all to vertical angles. I mean, would it still be true if you had vertical angles? Yeah, it'll still be true. But we don't need it to say it's true. All it has to do with the fact is these two have to add up to 180. Well, this and these two have to add up to 180. Two different concepts. One is collinear pair, one is interior angles. But ultimately, the end number you're getting to is 180. That's why it's true. But yeah, that wouldn't have anything to do with vertical angle. So try to do that. That's about as tough as it'll be on your quiz. You can get through even a lot of that right now.
I don't,
There's one piece you need to kind of
There's.
know to figure out. I know, there's more than three of them.
I know, but in the square, huge.
Yeah, I don't see how you could call that more than three.
the only part I wouldn't understand is the two excellent too.
Well, there's one, again, this is why I did the $20 thing. That's just a number. Remember, I said if it has a degree symbol, it's about the measure of the angle. That's got a degree symbol, it's just a measure of an angle.
I heard.
That's got a degree symbol, it's just a measure of an angle. So I'm gonna let you try to do some stuff on your own. Although I really want you to try this, but. You look anxious.
My mind.
So I'll give you a minute and then I'm gonna give you a hint in case you had no idea. So actually, I probably wanted to give you a full minute.
Why not?
Cause I don't want people to sit there and not have any.
Well, I'm trying.
What?
Well, I'm trying.
Well, no, that's what I'm saying. I want people to try, but I don't want people to sit there and do stuff. But. Well, I'm only gonna give you one very tiny hint. It's only one little thing. I'm gonna make sure you're understanding it first. Because it's not always super obvious, because there's a lot going on in this. What's the two concepts? I will tell you this part right now.
The, on it.
So sum of the interior angles equals 180.
Is that for,
And what else? All triangles. That's for all triangles. And what else? What was the other one, which is a review one we said? What's the other concept? I told you these two concepts together, 90% of triangle problems. So I'm gonna call it linear pair or collinear pair. The half circle thing, that's exactly it. You want to just call it half circle thing? Collinear pair is what I'm gonna call it, but it's the half circle thing. Those two angles have to add up. So if you just want to look through and say, can I use those yet? Do I have enough information in a triangle to figure out an angle based on the concept that three angles add up to 180, which you do actually. That's one thing you could do immediately.
that's what I'm doing.
Then there's another place where you can use the collinear pair, which will give you what you need. So then go back and use the sum of the interior angles.
So we're solving for what, 8?
You're solving for, again, make sure you read the question in geometry, because it's not always just about solving for a variable. And then there's actually a part B as well, which I put on. problems.
Is it just looking for a?
Well, first, in order to solve for the measure of the angle, which is this angle here, you gotta solve for a variable somewhere. I just want you to try to solve for the two variables first, and then we'll work them. One of them, you can immediately set an equation up and solve. One of them, you gotta do something else first. This is a example, if you didn't notice, example 3 in your
Well,
book.
that's what I'm trying to do.
We're gonna do it in your book.
If you look at y, can't you just be like, okay, well, that must equal 180, so then you just do 60, 60, 60, like, why?
No, absolutely. not. There is, so that came up again, you guys. This is what got you in trouble on the transversals quiz. I drew a, so again, you got to be careful about when you can never assume anything. You have to be able to prove something. That's why we did the whole
Oh,
lesson.
that's a
proofs.
perfectly straight line. It's 290 degrees.
But here's the thing, I could draw that by hand. And I could draw something that looks almost exactly like it, but by hand, you think it's gonna be perfectly 60, 60, 60.
Oh,
It won't, right? But it'll look just like it. So why can't you say it's 60, 60, 60? It'll look just like it. I'm going to be off, right? Which means you can't assume that that's 60, 60.
but it states that it's a right angle, which means that it's a perfect.
That's a right angle, but
For D.
why can't this be 59 and that be 61? Now, if you can prove why that can't be the case, then you can say that. But all I would do is if this is 59, it would just change this by 1 degree. If this was 61, it would just change that by 1 degree. And there's no reason why I couldn't do that. Now, there are other reasons why you might be able to state it if you really understood geometry. And that turns out to be true. So I don't want you to always assume.
Well, the reason why I assumed it is because the 290 degrees would have to be like this. They would have to be straight because it's 90 degrees. Because if it arches down, that would make it a 91 degree or something like that. It would make it.
But again, it's not, those are not the important angles. It's not about the 90. They are 90. The important angles are these. These are the important angles. Can you prove those are the same angles? If you can prove that, then yeah, you can say it. But you'd have to really understand,
Oh, because
because you don't have a transversal to say that it's
I
two
was gonna
lines.
say another thing.
Yeah, if this,
that it's
if
60,
this
60,
went
60.
through both of those, then you could say, yeah, well, I know this is congruent to that because of the, but that doesn't go through those all the way through the two parallel lines. Because again, think about it. I could slide point F up or down, right? No, that'll change the 60, so I can't use that example.
Well,
Again, I could raise that a little, and that'll change the 60 also. Again, you gotta be able to prove it though. Like just because I can draw a 60-degree angle in the middle, again, I'll be honest, I can't disprove it, but that doesn't mean I proved it either. So, and I do think it turned out to be 60.
and then it also means that the interior would be.
So if anything I do to change these changes that.
And then that would make that.
There's enough information to not assume. Let's put it that way.
Well, I mean, I'm sure you
Was
like,
anybody else waiting for?
I don't know, like I could solve it out if I took the time to, but I just felt like.
Oh, it's actually faster to do it the other way.
Like if I just looked at it, it felt like it was 60 because it was. Because it has to equal 180 though, doesn't it?
That's true. Yeah, because it's 3. So that is definitely true. You can definitely say these 3 have to be 180.
Can we solve them? I'm getting lost at the telephone.
Oh yeah, I'm sorry. I forgot to tell you the trick. Oh no. The trick is down here, or not really trick, but the one thing you need to know. That's what you need to jump to.
Well, I
What's
did,
that say?
They're both 90.
they have to equal.
So we know they have to be 180. If I know that one's 90, then by doing the math,
Oh my.
that has to be 90.
Oh, great.
Now, there was actually another thing you could have done with the Y's already. I need to know what, or what's true about angles. of a triangle. The interior angles of a triangle.
They all at equal angle.
If I can create an equation that only has one variable, and sometimes just write stuff out, like don't worry so much about trying to figure out what you don't know. Just do what you do know. What do you know about this triangle? So now I'm gonna get rid of everything. Is anybody writing anything?
Take it all.
All right, because it gets confusing the more I did. What do you know about that triangle?
That's it.
So let's make it, and don't we have something in every angle? There's something in there. Write an equation. If you can't solve it, you can't solve it, but the equation will still be correct. Sometimes that'll get you partial credit. So what's the equation gonna be? Ava, I want Ava to answer this. Ava, what's the equation? So I'm talking about this triangle right here.
What do you do with the bottom of the pool?
Well, right now, don't worry about solving. Like, again, this is the process you need to go through. Don't worry about figuring stuff out. Just do what you can do easily. We know that those three angles have to add up to 180, right? So let's just write it out. So what would I write? So we have a 90, so I can start with a 90 plus. What are the three angles of that triangle? Again, it's just what is in there. Like, you don't need numbers. You're doing too much. Just write what's in the figure. Y is in the figure, right? Plus Y. Plus what? What's the other angle? Yeah, we write all of that. If there is a degree symbol, it's the angle. I told you that hint. Yeah, you guys are worried, you're freaking out over seeing fractions and variables. I just told you, $20 is $20. You don't care what it looks like. It's just a number. That's just a number. We don't know what number it is yet. It is just a number. Subtract 45. And then that has to equal what? Yeah, because that's the three angles. Do not worry so much about what's in the angles. Even told you before this, don't freak out when I start putting a bunch of variables and numbers in an angle. It's still just an angle. It's just a measure of the angle.
Same thing for all of them.
Well, now my question to you is, can I solve it? Like, always, you can just create an equation that you know is true. Then think to yourself, can I solve it? What's the requirement to be able to solve an equation? Only one requirement was. Like, when can you solve an equation? When can you not solve an equation if you get it set up correctly? It is a one. If we have only write this down. And some of this stuff you need to be writing down on your own. I shouldn't have to tell you every single thing to write down. You don't know it, write it down. If you only have one variable in an equation, you can solve for that variable. We only have one variable in that. It doesn't matter that it's in two different places. Y is the only unknown number in that equation, the only variable. So we can solve for that variable Y. Now the math's a little tough in it to do it, so maybe we don't want to do that right now. But if you just set up the correct equations on a quiz, you get a C, even if you can't do the math. So just set some equations up.
I'm gonna set everything up and not.
Absolutely. We knew this was 90, so let's think about this triangle down here now.
What? Huh?
You'll see when I get out.
Oh,
So now let's go to that triangle where we have the x's. I don't want to do answer here.
well, we already know one's 90.
So we, again, same concept. Do we have something in all three angles of that triangle? Then set an equation up.
90
Whatever's
plus-
in that angle is the
Would
equation.
it be 90 plus x plus 8 then plus 2x minus 8?
And I'm going to put, you don't need the parentheses. I'm just kind of showing you that's what is one angle. X plus 8 is one angle. And then plus 2x subtract 2. That's an equation. It's a correct equation. And again, if we only have, you don't remember this, write it down again. If you only have one variable in an equation, again, that doesn't mean that you can't have it in multiple places. It's just gotta just be one letter. Then we can solve, and that's an easier one to solve, so try to solve that.
Wait,
What?
Wait, but when I did the X's, I just scrapped the 90 and made like 3x plus 6.
And we talk about that when we get into right triangles. If one angle is 90, then the other two have to, that comes up when we do right triangles.
Just gonna say, because that's just simply that removes a whole extra.
Yeah, it's the same math we do as the first step, is we would subtract and subtract.
It's not difficult to subtract 90 degrees.
Yeah, it's not, again, I'm showing that because I want us to understand the concept.
Said. Like that.
Oh, if you only have one variable in an equation, then you can solve for that variable. If you have two variables, you can't solve. There's too many different
It is what I'm saying.
possible answers. That's why you graph.
Not good with this.
For the algebra,
I know with the X. I used to.
yeah. I assign algebra problems in IXL. If you know you are weak in algebra and you want to do well in this class, you got to practice algebra on your own. There's, I think, 4 or 5 different IXLs that are just solving equations, solving for variables and equations. Some of them have variables on both sides of the equal sign. Some of them, like this one, only have variables on one side. But there you got a ton, you can practice IXLs forever.
Wait a minute, I think.
Yeah, first I'll give you a hint. If you don't remember, first you combine like terms. So if it has the same variable, it's a like term. If it doesn't have any variable. If it doesn't have any variable, it's a like term. So you can combine x's and then you can combine separately just the
I
numbers.
was making it more. Like I was trying to see what was X.
Yeah, we do a lot of, again, the algebra in here is not as tough as it was when you took algebra, but definitely still have algebra to do. So go ahead, I'll let you work for another minute. Get moving into the next lesson. I think this is the last thing. And like I said, even if you're starting to get comfortable, it's not gonna get any more difficult. I mean, I'm not gonna say the problem's gonna look exactly like that, but whatever figure it is won't be any more complex than that. This one would be hard out. I don't even think you're gonna have fractions on mine, but this one up here would be, but you have a fraction button. It's really not that bad. So you would just say y 1 plus 5/4 in your calculator. That would combine the two y's.
Consider.
You would say 1 because there's a, remember there, wherever you see a variable with no number, there's a 1 in front of it, right? So you would say 1 plus, and you can do a fraction in your calculator, 5 ABC 4, and then that'll be the how many y's.
So you know how like I did that solution with the Y, how it's 60 and like like all that. Because like we have that exterior angle thing, like that line that goes out, right?
Mm-hmm.
That would have to equal 180, like 60 plus that exterior angle would have to equal 180, right?
Exterior.
Like, because say there's a line going off that 60, right?
So in which direction?
Like to the up and to the right, like off that, like,
No, you couldn't say that because the exterior angle would be the whole angle.
up-
There's a way to do it. I see, I was looking at the wrong,
like
the
that-
exterior
that's what I
angle,
was saying.
but that's
that.
the exterior angle. That,
Well, I'm saying like you add them together and they would be 180, right? Like if you add-
yeah, but you were adding it, you gotta include this now too, if you're doing exterior.
Yeah, but that.
We have
that-
no
that-
idea what
That
that is.
exterior angle is 120, right? That's
Yeah.
one-
But how do you make an association with that?
But that would cut it in half because that's a straight 90-degree line, so that would make that Y.
Yeah, you don't know that. It can be done, but not that way. It's the parallel line and transversal. That's the right way to do it.
I have a question.
What I was thinking of the two parallel lines as the top and the bottom. We need to think of the parallel lines as the side. And then then we have a transversal cutting left or right. But yeah, doing this piece and extending it and saying, oh, well, that's, again, the reason it works is you get back to the fact that this is a transversal. That's why it works. But again, the parallel lines transversal as well.
It's
Which one are you doing?
blue.
Yeah. Oh, yeah, they're just numbers, right? Absolutely. Yeah, I knew there was a way to do it because I knew the answer was 16. But again, I want to make sure you're not assuming stuff. And it boils down to the fact that we have parallel lines because we know they're all 90 degrees, but it is the parallel lines transversal. It's only that we have a parallel lines as the up and down, and then that does make that a transversal cutting through, and we can say angles are equal. All right, so let's go ahead and just kind of quickly solve through. Y is part B, so I'm going to do just the blue. If you combine the x's, you get 3x. You combine the numbers, you get 96. How do I solve for a two-step equation? Oh, know how to
The
do that.
opposite map, basically, for the 96.
What do we do? Isaiah, I'm going to call on you, Isaiah. What do we do? How do I solve for x there? I combined all this for you and got it to that. You need to solve for x. What do we do? So we subtract the 96 from both sides. So we get 3x equals what? 84, is that right? Yeah, 3x equals 84. Divide by 3, divide by 3. So we get x is 28. I'm just going to tell you in the other class I spent more time on this. Is that the answer?
No.
Why not?
Let's find all the other letters that we're supposed to find each measure.
Well, that's not a letter at all.
That-
I mean, it's an X, but it's not what they asked us to do.
Are we still solving for the, wait, is this the green? Is this the green square or is this the?
So again, make this note again. In geometry, we've talked about it before. You are normally not just going to solve for a variable. You're going to either solve for the length of a side or for the measure of an angle. They want to know what is the measure of this angle down here from B to C to D. That's what they say, angle BCD. So they want to know what's the measure of that angle, which is that. It's called an expression, not an equation. So now, though, if we know x is 28, now we can solve and come up with an actual number.
Okay. What's me after that?
Well, what's the measure of that angle? See.
Didn't you just put 28 in?
No, does it say right here, the measure of this angle is x? Does it say the measure of this angle is x? Because we solve for x.
Yeah.
That's not what the measure of this angle is. What's the measure of that angle? Read it. I circled it for you. Read it. That's the measure of the angle. Well, you forget.
48.
Not 48.
Because like, don't
You don't math, it's just,
don't you put 28 in x? So you 2 times 20.
yeah,
It's 56.
But that's not, what would you get it 48? Like, just do it on the calculator again. Maybe they did it out of order.
28 times 2.
So again, so I'm just doing it up here. The measure of this angle.
I was saying hating.
Oh, everybody go around. He's not the teacher. That's why he's talking to me.
So again, you need to understand, just like when I tell you the $20 thing, that is some number, just represented with variables and other numbers.
So when it's.
It means angle C is equal to 2 times whatever x is. We didn't know that at the beginning of the problem, but that's what it's saying. Angle C is equal to 2 times x, and then subtract 2.
So when did you put 28 for?
Now we know x, right?
That's what I said.
Fine.
And then you.
Well, I thought you were saying put 28 in the angle. That's what the angle.
Oh, no.
That's what I thought you were saying. Then yeah, you're absolutely.
Okay.
So then angle C is equal to 2 times 28, because now we know what x is. If we solve for an unknown, we don't need the unknown anymore. Get rid of it and put the number in. And then subtract 2 Oh boy, that's weird that it doesn't. Right over that. So the measure of the angle then is 54. You can see the 54, right? I was gonna fix it so it showed up, but that's here. Let's do that. Oh, that's weird. There, that's. They didn't make it better. I just wanted just the 24 to. I give up. It's 54. And then we could solve for, if they asked us, we could solve for the measure of DBC. And that would just be 28 plus 8. So I'm not gonna go through and do why we gotta start the other lesson.
All right.
You can do that one on your own and we can maybe check it real quick next class, because like I said, if you can do this problem, you're in pretty good shape. We don't need to do a whole, I mean, I'm assigning you other problems. Oh, actually, here are your other problems, speaking of which. So you are doing, I think it's page 277, where it starts. 1 through 17. Then, and you do exactly what the book, so you need to write this down, so hurry up, get to that page so you can write the instructions, because I'm giving you some different instructions from what the book says. So from 1 through 17, just do what the book says. But then I want you to do number 24 and number 34. 77, keep up. I'm glad you guys are back. Which took you a while, but
177.
or 277. So again, 1 through 17, do what the book says. But I want you to do 24 and 34, which will be on later pages. 24 and 34, just solve for the angle. It tells you to do some other stuff in the book. Don't worry about what they did. Just solve for the angle, just like we did here. Baker. Nope, just 20. The reason I picked those is they have images on them. So they're already giving you images with something set up in it.
That's a good picture.
Yeah, if anybody wants to take, I mean, it's actually super confusing probably, but you want to take a picture of that one, since we're not solving Y out, then you can go back and try to figure it out on your own. Oh, you don't have the pay, I see what you're saying. I got you. There is an online book too. Sometimes that's better to get to know. 24 and 34, you're just finding the measure of each angle, 3 internal angles. I don't think the figures are even that complex or anything in them. All right, so we got to go through and do the new lesson. So the next lesson.
What? We're doing 2 lessons today?
Well, we're starting the next one. Back to way behind again, because last week we took a whole week to do transformations. It was supposed to be 1 day. But that's just the way it's gonna go in geometry, is they don't ever give us like any review time or catch up time or anything. I'm even cutting some stuff out that we're supposed to cover. And we just don't have time. It's just not enough time in the day. Wait, where am I? Oh, really quickly, this is just something in your book that I'll mention. If you have a right. Actually, if you have a triangle, I won't even say it's a right triangle. If you have a triangle and one of the angles is 90 degrees or more,
The other one's
right? The other 2 angles have to both be less than 90, because they can only add up to 180 total, right? So if I have 180 total degrees, one angle is already 90 or more than 90. Well, then I'm left with less than 90 degrees to split between the other 2 angles. So the other 2 angles have to be less than 90 degrees. I don't think that's gonna, I mean, it's not gonna come into play on anything I do. They could theoretically give you more of a conceptual thing, like a sort of a proof kind of thing almost, that has you, that makes you think about that. But again, if one angle is 90 or more, well, then that means I'm gonna have less than 90 in the whole triangle, and I gotta split that between 2 other angles. So. There he goes.
What's his grade?
I don't talk about anybody's grades, you know.
Yeah.
Gotta stop. I don't even know. I'm jealous. I lay in bed like an hour to get balls, and fall asleep, I'll get to the walls, and then you have to get off. That's probably not enough, but that.
Just let me put the calculator out.
All right, so next, congruent triangles. We're not doing this whole lesson today, but it's the intro. This is the one that I told you the IXLs are some of your quiz questions.
Okay,
So I'll tell you which one, 5-2, just keep turning until you get to 5-2.
Did we get practice time today?
Not today, hopefully tomorrow in the skinny day, we'll just be able to practice all of this. That's the goal,
Yeah, this class.
if we can get through it. I'm not gonna go over any of that specifically, I'm just gonna tell you some of the stuff you need to know. When you have congruent triangles, what it means technically is that you can take an original image. So one of the triangles would be your original, and you can transform it. That's why we did transformations first. You can flip it, you can rotate it, you can slide it. Somehow you would get it to land exactly on top of the other image. That's truly what congruent images are. Somehow you can flip that, turn it over, slide it, and it would land exactly on that image. What it also means is that every part of this image has a congruent part of this image. So each side, each angle would match up exactly. So if you are like doing easier stuff, they'll just give you congruence marks and they'll just tell you what's congruent. This side is congruent with that side because it has 4 congruence marks. This side is congruent with that side. Sometimes you can just visually tell because every side looks very different. Sometimes you can't, which is what I'm going to show you in a minute. Same thing with angles. We just make them a little more curved. 1 mark means it's congruent with W. 1 or 2 marks means it's congruent with X, etc. Now, here's the thing. It won't be that. I'm not going to give you all the congruence marks, or I'm going to give you some congruence marks that are the same. Like maybe some sides both have 3, and you got to be able to figure it out. If they give it to you, the best way, the go-to way to figure out which parts are congruent is using the names. So write that down. Big capital letters. You use the names of the figures. Doesn't matter if it's triangles, rectangles, pentagon, other quadrilaterals, any polygon. You use the names to determine which parts are congruent. Assuming that the figures themselves have to be congruent, which is what that's saying. So if they're telling you 2 figures are congruent, you match up angle A with angle W. Angle B is congruent to angle X. Angle C is congruent to Y. D is congruent to Z. That's the way you do it to guarantee you've done it correctly. If you try to visually look at it, it'll work sometimes. It won't work sometimes. I can show you one where it won't work. And then if you were going to do the line segments, it's similar. Line segment BC, the 2 middle letters, is congruent to line segment XY. You just take the 2 corresponding letters from the names, and those are the sides that would match up. So again, big capital letters, use the names if they give them to you. Sometimes they won't. You actually have to name it. That's one of the questions on the quiz, is you have to name a figure correctly. So you would have to match up angle with angle, use the names to determine which parts of the image or the figures are congruent. They go in order. So A is congruent to W, B is congruent to X, C is congruent to Y, E is congruent to Z. I mean, you'll see, and I'd rather you write in your own
Which
words
part?
anyway.
Tell me which part of it.
Just which parts of the figure are
Oh.
congruent. And there are other ways. Sometimes you'll have markings like that, which will allow you to do it, but on a more difficult problem, you're not going to have that. Which is what I'm about to tell you. So in that particular figure, Oh, we erased that. Oh, weird.
Just the names. of it.
So if I gave you those two figures, hold that thought. While I erase the answers. There we go. You would say, and I tell you, those are congruent rectangles, right? They're congruent. You would say, well, yeah, that's easy because they're all 90-degree angles, right? And you would say, yeah, well, angle A is congruent to angle E. I would be a logical assumption, right? You would be wrong.
Of course we do.
Why would you be wrong? Nope. Nope. Math is fun and amazing and the best thing ever.
It's still,
Watch your mouth.
it's still difficult.
It's really not. It's a bunch of processes and you guys don't stay very organized, so. Yeah, I'm not gonna say there aren't some. A lot of times it is just, you're just not writing the process.
What am I
You're
not-
listening to it, thinking you can remember it, and you're not gonna remember it.
What am I not understanding?
I know, right? You look at it and it looks like A is congruent to E. What did I just tell you though? Use what?
Where did
What did I tell you?
Where's the B?
Just, see, again, I just told you this, nobody wrote it in. Actually, you should have written in capital letters and said write it in
Use the
capital letters.
names to determine which part of the
So what's the name? What figure is congruent to what figure?
A, B, C.
Oh, H.
A is not congruent to E. Congruent to H.
Wait,
Back down from it. I wasn't sure if you were still.
Always upside
I
down.
looked at you and I thought you shook your head like, oh no, let me,
Upside down and under.
I thought you got scared.
I'm
I got
lost.
scared. I thought.
I'm lost.
I was just saying you're scared me at all. I think you got scared.
I'm so lost.
I looked at your eyes. I saw fear in your eyes. I looked you in the eyes. I saw fear in your eyes. Oh, that's when you were scared. I knew you were scared at some point.
I didn't say that.
Oh, so you're scared though. You admit you're scared. That's all I want, is for you to admit you're scared.
It's just an up and my down.
So again, what this means is hey, look at that. So we're flipping and maybe flipping it twice, that rectangle to get it to match up. Again, they are both 90 degrees. I'm not saying they're not 90 degrees, but you have to match up angle with angle when you're given
How do you?
the names of the figures. You look at the name. That's why in big capital letters, I had you write, use the name to match up the congruent parts. And the opposite will be true. If I ask you, or I should say, when I ask you to name the two congruent figures, and I don't give you the names,
Don't give us the names.
then I'll give you markings. Now, again, they probably wouldn't be a rectangle if I did it. But I'd give you something like that. And then I'd give you something like this. Actually, this may not be possible, but it will be possible in the quiz. So I'd give you something like that. And you would just say, okay, well, when I name it, I have to make sure that I take A and match it up with G. So the name would start like that. I would just write A and G first. Yeah, again, I don't even know. Sometimes it's not possible, but I would make sure it was possible.
See the H.
So yeah, again, let's see. I don't even know if this is possible
And then
because
E to F.
there is an order that wouldn't be possible. So we would say 8.
Yeah.
So
It's
G
just
to
flip
A.
it once.
Yeah, like see, that doesn't work because we went from A down to C. So I wouldn't be able to do that order. I'll make sure it matches up. But just, again, the point is use the name, or if I'm telling you to name it, make sure you keep the
Okay.
parts that are congruent in the same order.
What if you give us the name, bro?
Then you use the name to figure out what parts are congruent.
Yeah.
Right? It's one of the two. Either I'm going to give you the congruent parts and tell you to name it, or I'm going to give you the name and
Like a
ask
matching
you
game.
something about what's congruent.
It's like a batching game.
Yeah, I mean, again, it's one is the opposite of the other, or the reverse of the other. But you need to understand that that's what truly determines. Now, if you have congruent symbols, then you can use those too. But I'm just saying you won't always have them. Sometimes all you'll have is the name. Let's see, that might be the last thing. I feel like there's one more thing. Oh, yeah, there is one more thing. All right, so name this. So go ahead and name that. Yeah, you should have time. 6 minutes. That's the last thing that we need to do.
Only for having three.
There's one little tricky piece of it. I mean, you can draw it really quickly as long as you understand the name. If you just want to do it yourself from the figure, just to see if you can do it. This is not super tough because all of the angles have different symbols, so that makes this pretty simple. Two of the sides do have the same symbols, but I'm going to show you how you use that. The point of this particular question is I guess you will have to do that, but because this is not about naming, I probably won't take points off for naming it correctly if I can understand your answer. Now, the order is theoretically important. I don't even know if I would take off for that. So if you did a line segment and you had the letters reversed from what they should be, technically that's not the way you should do it. But also technically it is still the same segment. Those are both congruent segments.
How do we do?
I know, right?
P, wait.
Because some of them have the set. Wait, P and Q. You should know how to do P and Q.
The second part. The P.
So I mean, you can just use the picture for that.
Basically the same thing we just did.
Yeah.
For the top
It's for
part.
the side that
P.
it just has a straight.
It was T. Yeah. Right. Oh, okay.
So the hard one for that though is when you get to the ones that I circled. Because you got two sides that have three in both figure. You got to figure out which ones match up.
I work.
Well, you should have done it. And naming the very last thing should be pretty simple. You just go in the same order as the letters using what's in the angles. I'm going to zoom in and we're going to do it real fast. There's only one that should be remotely tricky on this. And that would be, again, the ones that I had circled that have three.
Yeah.
How do you get confused when I go in where I go? What are you having? Oh,
No.
Oh, I'm just gonna do it real quick, sorry, because I don't like on this. We got like 2 minutes. Well, you are special. All right, so I'm not gonna worry about the angles. All the angles have their own symbol. So if it's got 4, it's got 4. If it's got 1, it's got 1. The angle should be pretty easy. I'll explain quickly. If you have one mark for a side and one mark for a side, you should technically name it from the angles that have 1. So we should start with a P and a G and go to the one that has 2. So F and then Q. Again, if you happen to reverse it, but you had the correct segments, I wouldn't even count it wrong because that is the segment that's congruent. Technically, we should start correctly. Here's the one that's tricky. I have 3 and 3 there, but I also have 3 and 3 there. How do I figure it out? How'd you figure it out?
I figured out.
Yeah.
Because, I got sheet F and I was like, okay, well, F. It's the line. So that's what I thought.
So here's how you figure it out. I don't know what you said.
The line. Yeah.
Look at the angles.
That's what I
We'll look
thought.
at the angle. Yeah, look at the angles. That 3 is in between the 4 and the 3. So I need to say, okay, which 3 is in between the 4 and the 3? Well, this one is 4 and 3. So that would be congruent with that. So again, this 3 is in between the 2 and the 3. Well, which one is in between the 2 and the 3? Well, this one is in between the 2 and the 3. So EF be congruent with RQ. I don't know how they did it, if they had different orders, but just remember, look at the angles. If you have sides that have the same amount of congruence marks, then you got to figure it out by determining from the angles which ones are congruent. All right, so we got through everything today. I haven't assigned problems from that, so you have the problem. We'll finish this tomorrow and I'll assign problems. And hopefully you'll have a good, at least 20 minutes to practice. And I'll tell you which IXLs are going to be good practice. And I will stop that recording. The other recording has a fire drill in the middle of it. Well, actually, it didn't have it in the middle of it because I stopped it, but I had to make 2 parts to it. This one will be all one, so I'll just post this one instead.